We go again. So we've been talking about the nervous system, the endocrine system, the glands, blah blah blah. Now we're going to talk a little bit about the different pathways that all of these systems link through. First is the SAM system, the sympathetic adrenal medulla axis. So in that moment of stress, we've talked about the hypothalamus being a real bell ringer, to let us, when the alarm is sounded, the hypothalamus gets busy and activates a whole bunch of systems. It signals the sympathetic nervous system. Now we know that the hypothalamus has a lot to do with our endocrine system, but it also signals the sympathetic nervous system to activate. Now remember, the hypothalamus is in the brain, but it links through a neural pathway called the sympathetic preganglionic neuron to the adrenal medulla, which is the interior of the adrenal gland, which sits on top of the kidneys. Okay, so it links to the adrenal medulla, which again is the interior of that adrenal gland, via that neural pathway, and that adrenal medulla secretes epinephrine and norepinephrine. Remember, in that 80-20 kind of ratio, sorry, to partner with those neurotransmitters of the same name to reinforce the fight or flight response to the sympathetic nervous system. So that's how all these work together, backing each other up. The neurotransmitter system working through the neurons very quickly, the hormones working a little more slowly, and all happening at the same time. So then we have the HPA axis, which is such a big one. I talk so much about the HPA axis in my other classes. I have a video here for it as well. So the anterior hypothalamus releases corticotropin-releasing factor, CRF. So we're starting with the hypothalamus. Everything seems to start with the hypothalamus, right? It's kind of, again, that starting point for all of these axes and all of this to take place. CRF, in turn, so when the stress response starts, the hypothalamus releases CRF. CRF activates the pituitary gland, which is in the brain, which then releases beta endorphin, which is a natural opiate or an analgesic, kind of a numbing agent of sorts, and adrenocorticotropic hormone, ACTH, which travels through the bloodstream to those adrenals on the kidneys and activates them. So the hypothalamus releases this CRF, which then activates the pituitary, which then activates the adrenals, which release the cortisol. The cortisol increases the metabolism, alters the body fluids, increases the blood pressure. So negative feedback. As cortisol levels rise, they begin to block the release of CRF from the hypothalamus and ACTH from the pituitary. And then ACTH levels drop, which then leads to a drop in cortisol level, which can lead to immune suppression over time. So if you remember, that's one of the things that cortisol does, is it suppresses the immune system by using some of those white blood cells. So cortisol is necessary, but too much over prolonged periods causes damage. And that's one of the ways it can do it. As it rises, it blocks these things. Anyway, the immune system can get suppressed over long periods of time, which can then lead us to illness. Cortisol is necessary, but in also too much cortisol tends to block the hippocampus. Now remember, hippocampus is about memory. So if our memory blocks, if we're really stressed out, so say you're really stressed out and you're studying, if the hippocampus gets blocked, then it's really hard for the hippocampus to work the way it needs to help with memory. I always tell my students when they're doing their mindful exercises, a really good time to do those is right before you work out, right before you study. spend some time de-stressing before you study so that the brain is all integrated and activated and online in a way that it needs to be for these parts of the brain to work optimally. All right. Bonk, bonk. What's happening here? Sorry, something went a little crazy. You can look at this on the PowerPoint when you want. So another thing we have here is vasopressin, the antidiuretic hormone made by the hypothalamus and released by the pituitary gland. It regulates and balances how much water is in the blood. So it tells the kidneys to reabsorb water in the urine and return to the blood when more is needed. So if um, it's looking at how much water, when it needs more water, it lets the kidneys know, and then more water is released and returned to the blood. It instructs the kidneys to conserve water when it's needed. In this way, it can alter the blood volume, how much blood we have. More water in the blood equals greater blood volume. The more blood you have running through your system, greater blood volume increases stroke volume, how much blood the heart pumps with each contraction. Greater stroke volume increases blood pressure, and during stress, blood pressure is raised. So this is vasopressin is released during the stress response, and this is one way that the blood pressure gets raised. When stress is chronic, ADH can continually increase that blood pressure even when we're at rest, and it causes hypertension. So again, things get stuck in the on position in chronic stress. The system just continually is telling itself to do all of these things for energy metabolism, for energy use, to up the blood pressure, and especially if the stress is emotional or social in nature and not physical in nature, then we're not utilizing the energy and everything is kind of getting stuck inside the system. Okay. So we have the thyroxine axis. So stress creates a very high demand on the body, a demand for greater energy consumption, greater metabolic rate. Metabolic rate is regulated in most cells by thyroxine, a thyroid gland hormone. Like the SAM system and the HPA, it all begins in the hypothalamus, which triggers the release of thyrotropic hormone release factor, TRF, to the pituitary. Remember, the pituitary is known as the master gland. It has a lot to do with a lot of these things. Pituitary stimulates the release of thyrotropic hormone to the thyroid. TTH allows the thyroid to release thyroxine and triiodiphyronine, sorry, to increase metabolism. So the end result is an increased metabolism, increased metabolic rate, increase of what we need in the blood to use for energy production. Powerful enough to double metabolism. Very slow to synthesize, 10 days to 2 weeks before the effects are even noticed. Metabolic rate of thyroxine, nervousness, anxiety, insomnia, increased heart rate, excessive sweating, shortness of breath, diarrhea, fatigue. So when all of that gets going, we get that stress. It's almost like all the physiological feelings, all the things that can happen during stress over a prolonged prolonged time. Amplifies impact of epinephrine, leading to more intense stress response. It's long lasting. So why some people under chronic stress struggle to return to baseline levels. So remember, you've got the gas and you've got the brake. But if you have this stuff in the blood system and it takes a long time to synthesize and then to leave the system, then you get, it's kind of constantly going. And then if you have stress going through that time period, it just keeps going. And that's why you get chronic stress and never get back down to the baseline that that kind of load on the system stays and changes the whole baseline of the system to expect high high energy consumption needs. All right. So here's just a little table for you. The body has several backup dynamics to help ensure physical survival. Here, these dynamics are broken down into categories. Epinephrine and norepinephrine from the sympathetic nervous system. So the neurotransmitters, immediate effects, 2 to 3 seconds. From the adrenal medulla, so those are the hormones. Intermediate effects, 20 to 30 seconds it lasts, and it can possibly last for minutes. So, if stress continues over time, though, it continues to happen. Prolonged effects, ACTH, vasopressin, thyroxine, neuroendocrine pathways, minutes, hours, days, or weeks. So we can see how all of this can just kind of continue on in the system. And if we never take time for the break, we never allow that opportunity for the system to return to baseline, then it's just constantly ramping up, and these things continue to happen. All right, so I'm going to stop here. Well, there will be one more. I know this has been a very long section this week. There's a lot of information here, and I think it's good info. We're going to stop here. There will be one more section on traumatic stress, PTSD, and even post-traumatic growth. Be well. See you next time.